All right, y'all. Today we're going to be talking about writing linear functions. So a little bit of a pivot. We started talking about slope, then we started talking about graphing linear functions. Today we're going to actually be writing those linear functions. And we're going to be working with those same different types of linear functions that we've seen so far. The first off is our slope-intercept form, which of course we do know as y equals mx. As y equals mx plus b. And of course, we know that m is our slope and that b as our y-intercept. Then we have our point slope form, which our point slope form can be useful if we don't have the y-intercept, but we do still have slope because once again, it does involve that slope, but then it involves that actual point, that y1 and that x1. So y minus y1 equals m times x minus x1. And of course, this is my point. And my m, once again, is still that slope. And then last but not least, and we're not going to focus on this one as much with today's notes, but it is another equation that we can, of course, use to write our linear equations. And it really comes in handy when we actually don't have a situation that's represented by slope, but it is our standard form equation. And of course, our standard form equation is ax plus by equals c, with that c representing some sort of total. And then those A and those B's usually representing the amount or the cost of whatever variable is Y and whatever variable is X. And they can kind of vary depending on the equation. Okay, but like I said, we're going to focus on these first two, slope-intercept and point-slope form. And we're going to kind of look at different questions in different situations. And depending on the information, dependent on the situation, whether we want to use our slope-intercept equation and form, or if we want to use our point-slope form. So let's start with some verbal descriptions. So number one, we want to write the equation of the line where the slope is -5 and the y-intercept is 4. So there's two key pieces of information they gave us. They told us that the slope is -5, and they told us that the y-intercept is 4. So since they gave us slope and the y-intercept, we want to use that slope-intercept form because we have those two pieces of information already. So our equation would be y is equal to, our slope is -5, so -5x, and then our y-intercept is 4, so +4. Relatively straightforward when they give us that information verbally and we're just plugging into the correct equation. All right, on number 2, they want us to write the equation of the line that passes through the point 1, 5 and has a slope of 2. So once again, just like on number 1, they did give us a value for slope, but this time they just gave us a general point, not the specific point of the y-intercept. So instead, we're going to use our point slope form instead of our slope intercept form. So our point is, of course, 1, 5, and that's going to represent our x1 and our y1. So when we're writing our equation, it is y minus y1, so y minus 5. And that's equal to m, so equal to our slope of 2. And then parentheses x minus, and then our x1 value is that 1. Okay, so we can see the difference. Number 1, they gave us the slope and the y-intercept, so we use slope-intercept form. Number 2, they gave us the slope in a different point, so we can use point-slope form. Okay, and we could, if we wanted to, convert any equation that's in point-slope form over into slope-intercept if we wanted to maybe use it to graph, or if maybe our answer choices were only given in slope-intercept, we could pretty easily do that by distributing the 2 and moving over our 5. We're going to do that on some of ours today. We're not going to worry about it for right now on number 2, though. Okay, so our next set is graphical, so a little bit different. Verbal was very direct. They told you what those pieces or what that information needs to be. With a graphical representation, I've shown you what the lines are, but we're going to have to pull that information out of the graph. Now, technically, graphical, you can actually write this direct into slope-intercept or into point-slope form. I'm going to start with slope-intercept form because I think it's the one that makes the most sense. if we can see the y-intercept and the slope. But we'll also write it in point slope form so we can kind of see. So on number 3, we have our linear function here, and there's 2 things we want to look for. To be able to write our linear equation, we need to have that y-intercept and we need to have that slope. Now we know the y-intercept is where our graph crosses the y-axis. So we know that our b is equal to -5. And then we can find our slope by taking any 2 points. I usually like to start with the y-intercept and then finding any other nice point where we cross, like we do right here at 3. And I can just find that rise over run. So to get from this point to this point, I would have to go up by 5 and run by 3. So that means my slope is going to be rise of 5 over a run of 3. So now that I know what my y-intercept is and I know what my slope is, I can write that equation in slope-intercept form. So y is equal to 5/3 x and then -5. Okay. And of course, if I wanted to, I could also write this in point slope form. I would use that same slope that we found of 5/3. And then I can pull any other point off of my equation. Go ahead and see if you can practice this skill on number 4. So same thing on our graph on number 4. Go ahead and identify that y-intercept, identify the slope, and then use it to write an equation. So go ahead and pause the video and try to do this without me. All right, and on number 4, we can clearly see a y-intercept of -1, and then taking that y-intercept point and going to my point here over to the right, I would have to go down by 2 and then to the right by 5. So that rise is going to be -2 run of 5. So that gives me a slope of -2/5. And then, of course, x minus 1 for my y-intercept. Pretty straightforward to actually go ahead and plug that into slope-intercept form. And once again, if I wanted to, I could write this in point slope form, just pulling out any point. You can use the y-intercept. You can also use any other point on the graph, and it would work exactly the same. Okay, so let's pivot and let's look at our third different way that you could really be kind of given this information, and that's our tabular representation, or if it's given to you in a table. Okay, and if it's given to us in a table, same thing. We want to try and identify the slope first, because the 2 equations that we're using, we're always going to use and look for that slope. So we've done this a little bit in our slope unit, but if we're given a table, we can find that slope by just looking for the change in y over the change in x. From -5 to -7, I would be subtracting by 2. And then again, from -7 to -9, I'd be subtracting by 2. So my change in y is definitely going down by 2. And then from 3 to 0, I would be subtracting by 3. And from 0 to -3, I would be subtracting by 3. So my change in x is definitely -3. So then for my slope, it is always change in y over change in x, or rise over run. So -2 over -3, which of course would simplify to be a positive 2/3 for my actual slope for my equation. Okay, now the next piece of what we're going to identify depends on the table. If our table includes the y-intercept, and remember the y-intercept is when one of our points has an x value of 0, then I can use slope-intercept and go ahead and plug that directly into our slope-intercept form. If our table does not include the y-intercept, then it's a little more difficult to do slope-intercept form, and instead it would be more beneficial to do point slope form. So looking at our table, we do have this point right here, 0, -7, which has an x value of 0 and a y value of -7, which means because x is 0, that means it is crossing the y-axis. So that does mean that our b value and our y-intercept would be equal to -7. So now that I know my slope, I know my y-intercept, I can plug both of those into my equation. Y would be equal to positive 2/3 x and then -7. So relatively straightforward still. The biggest piece of this is just solving for that slope and then being able to identify the y-intercept. Okay, let's look at one that's maybe a little bit different in number 6. So same thing, we're given a table. Same first step. We want to go ahead and identify that slope first. So from 1 to 2, my y value is going up by 1. From 2 to 3, my y value is going up by 1. So my change in y is definitely 1. From -2 to 2, we are going up by 4. From 2 to 6, we're going up by 4. So my change in x is definitely positive 4. So my slope would be positive 1 over positive 4, which of course we can just write simply as positive 1/4. Those positives aren't going to cancel each other out. They're just still positive. Okay, now on this one, on number 5, we had a point that was the y-intercept because x was equal to 0. Here, we don't have that point where x is equal to 0. So instead of writing this in point-slope form, instead of writing this in slope-intercept form, we're going to actually use our point-slope equation. And remember, our point-slope equation is that y minus y1 equals mx minus x1. And I have lots of points to choose from. I could technically use any of the points here. I'm going to go ahead and use that very first point. Sometimes you might, if it's a multiple choice question, you might just check, okay, which point does it look like might have been used to write the equation. But you can technically use any point. So we're going to use that point -2, 1, -2 being my x1 value and 1 being my y1 value. So we're going to go ahead and write our equation y minus y1, so y minus 1, and that would be equal to our slope, so 1/4, and then our x minus x1, so x, and then it's -2, so minus -2 would be equal to +2. Important thing to note because of that x minus x1. If we do ever plug in a negative number, and same with our y minus y1, if we ever have a negative number, it would switch over and become positive. So an important thing to note. Okay, now, yes, we wrote this in point slope form. Let's say your final answer, though, you need it to be in slope intercept form. Maybe you want to graph it. Maybe you want to use it for some other purpose, or maybe your answer choices are just all in slope intercept. So that's okay. I can totally convert this to slope intercept form really simply. And all I need to do is I just need to distribute out that 1/4 and then shift over that -1. So the first thing I'm going to do is I'm going to multiply both of these terms inside by that 1/4. That's going to give me a new equation of y minus 1 is equal to 1/4 x. And then 1/4 times 2, a fourth of 2, that would be 2/4 or 1/2. Okay, and then from here, see how I have that -1 still hanging out with my y? I just need to get that to the other side. So adding 1 to both sides, +1 and +1. That -1 and +1 are going to cancel out, which would leave me with 1/4 x. And then, of course, 1/2 plus 1. You could use your calculator if you needed to find this. It would be 1.5 or 3/2, or even if you want to write it as a mixed number, 1 and 1/2. I'm going to go ahead and keep it as a fraction because our slope is as a fraction. And I'm going to write it as 3/2 when we add that 1 over to the other side. And of course, if you're ever unsure about that, y'all, you can type 1/2 plus 1 into your calculator. And then you can use that math fraction option if it gives it to you as a decimal and you want it to be a fraction. Or of course, if you wrote this as 1.5 instead of 3/2, that would still be totally correct. And you could leave it like that. Okay, so that's kind of all the different ways the information could be presented to us verbally, graphically, and from a table. Now let's kind of pivot a little bit and think of what's all the different pieces of information we could be given. All of these kind of really focused on being given the slope and points, but those can kind of come in different ways here. We could be given the slope and the y-intercept. We could be given a point in the y-intercept. We could be given just 2 random points, and we could be given the slope and a point. So depending on the actual information that we're given, could vastly depend on what kind of equation we're actually going to be able to write with and how we're going to be able to write it. And one of the things we want to keep in mind is typically our ultimate goal with linear equations is to get it into that slope-intercept form because, of course, that's the most versatile. We can use it to graph. It's the way you're going to see most of your linear functions written. It's what we consider almost the most important or the most used version of slope-intercept. So anytime we're trying to get to that goal, then, of course, there's a couple of things we want to find. Is the first and foremost is we want to find that slope. So if we can find slope, we already are one step there to getting that m value. Okay. Then after we find slope, we want to find that y-intercept. Okay. And then, of course, if we find slope and we find y-intercept, we can go ahead and plug it straight into our y equals mx plus b. If we don't have a y-intercept, then, of course, we should have some other point that we can use. And so we're going to use point slope form. And then solve for y. Because if we use point slope and we solve for y, then that's going to get it into that y equals mx plus b. Okay, so let's look at some examples. So first and foremost, and this is going to be very similar to one we saw earlier, if we're given the slope and the y-intercept. So m is equal to -2, b is equal to 5. This is super straightforward. We can write this one directly into slope-intercept form. Our slope is -2, so -2x. And then our y-intercept is 5, so plus 5. Easy peasy, we're done. We already got it in that slope-intercept form. Okay. The next one that we could get is we could be given just a random point and the y-intercept. So if we're given a random point in the y-intercept, we do already know one piece of information. We do already know that our b value is equal to 5. Okay, but we don't have that first step that we need. We don't have our slope right now. So to be able to find our slope, we can use our slope equation. Just a reminder, our slope equation is m is equal to y2 minus y1 over x2 minus x1. Okay. And so anytime we're given a point, we can take any of these 2 points and call them x1, y1 and x2, y2. So let's just go ahead and say first point is x1, y1 and second point is x2, y2. And then we're going to plug that into our slope equation here. So m would be equal to y2, which is 5, minus y1, so minus -3, over x2, which is 0, and then minus x1, which is 2. And just simplifying this a little bit more, m would be equal to that negative and negative is going to cancel out and become a positive. So 5 plus 3 is 8. On the bottom, 0 minus 2 is -2. 8 divided by -2 would be equal to -4. So we now have our y-intercept and we have our slope. So we can write that in slope-intercept form, y equals -4x plus 5. Okay, so we had to do a little bit of extra work to solve for the slope, but nothing too crazy, nothing too difficult. Okay, our next one that we could see is what if we were given the slope and just another random point? So we are given slope, but we're not given the y-intercept. So if we are given something like that, slope and a point, but that point is not the y-intercept, then we don't need to do that extra work for our m value. We already know our m is equal to -4/5. Okay, but we do need to go ahead and plug this into our point slope form instead of our slope intercept form, because right now we don't have that y-intercept, so we have to use point slope instead. So our point slope, remember, is that y minus y1 equals m times x minus x1. So we're going to do y minus, and our first point, remember, this is always x1 and y1. So our y1 is 1, so y minus 1. And that would be equal to our slope of -4/5, so -4/5. And then parentheses, x, and it is minus -5, so minus -5 is going to give us that plus 5. And that is it. We have written our equation in point slope form. And of course, if we didn't have to convert, we could leave our equation like this. But if we needed our equation to be in slope intercept form, we can do a little bit of extra work by first distributing and then shifting that value over with y to the other side of the equation. So first and foremost, I'm going to multiply both of these by -4/5. So rewriting our equation, that would become y minus 1 is equal to -4/5 times x. And then -4/5 times 5, that is going to cancel out the divide by 5 and the 5 and leave us with -4. And then getting this -1 to the other side, I can add by 1 and add by 1. And this one's a little easier than the last one we did. because -4 plus 1 is just going to give us -3, and then -4 x. That -1 and +1 are going to cancel out, and of course we do still have our y equals. So after we've written in point-slope form, we can do a couple of quick steps to convert it into slope-intercept form. So that gives us our new equation of y equals -4 x. And then that's, of course, going to be minus R3. Okay, so we've seen 3 different ways. Each of them, I would say, kind of progressing in difficulty. The last one we're going to see could be the most difficult, and that's if we're just given 2 random points. So we're not given the slope, we're not given the y-intercept, and these 2 points, they're just 2 points on our graph. So if we have this situation, it means we're going to have to do the most work because we're going to have to solve for our slope, and we're going to have to write it in point-slope form, and then solve it to be in slope-intercept. So first and foremost, we want to write that slope. But let's go ahead and denote our x1, y1, and x2, y2, because that's going to help us out here in a second. And so our slope equation is that y2 minus y1. So m is equal to, and our y2 is 2, and our y1 is -2. So 2 minus -2. And on the bottom, our x2 is 5, and our x1 is -5. So 5 minus -5. And just like we've talked about before, both of those double negatives are going to become positive. So that would make this into 4/10. And 4/10 we could reduce to be 2/5. So we found our slope. Now that we have our slope, we can actually use either of our 2 points for our point slope form. Let's just use that first one for our x1 and our y1, -5 and -2. And we're going to plug that into our point slope formula. So y minus y1, so y, and then because it is minus our y1, that minus -2 is going to make it into +2. And that is equal to our m, which is 2/5, parentheses, x. And then once again, because it is minus x1, it's minus -5, which is going to make this into +5. So from here, just like I did on my last one, I've written it in point slope form. I could leave it here unless the question requires me to go ahead and write it into slope intercept form. So in that case, if it does require me, I can just do those 2 steps of distributing my slope and then moving over my y1. So first and foremost, let's multiply both of these by our slope. So y plus 2 equals 2/5 x. And then 2/5 times +5, that 5 and divide by 5 are going to cancel out and leave us with just 2. And of course, y'all, if you're ever uncomfortable with that multiplying of the fraction by our x1 value inside the parentheses, you can always use that calculator to do that calculation for you. Okay, so from here we have y plus 2 is equal to 2/5 x plus 2. I just got to move this number over with my y to get it by itself. So -2 minus 2. And we're going to get it to cancel out over on the left, but we're actually going to also get it to cancel out over on the right, and that's okay. All that means is that our y-intercept is 0, which means this graph is going to go through the origin. So we get the simplified equation of y is equal to 2/5 x, and then you could write +0, or you could just leave it as 2/5 x. Either would be fine. So for our final slope-intercept equation, y is equal to 2/5 x, and like I said, you can write +0, or of course we can just write it as y is equal to our 2/5 x. Either would be fine as your final answer. And that's really all there is to it, y'all. With writing linear equations, as you kind of probably noticed, it's really just using those 2, slope-intercept form and point-slope form, and you could kind of get the information presented to you in lots of different ways. So it's just knowing, depending on what information I have, what equation am I going to use, what extra steps might I have to do. And of course, getting better at this is going to come with lots and lots and lots of practice.